Example 4 again wants us to solve the given triangle. This one's a little different because now I have two sides. I don't have any of the angles, so I need to solve for this third side and two of the angles. So let's start by solving for that side. So we're going to solve for t. There's a few ways we could do this. We could actually solve for angles first and then do it, but we have two sides. We also have the Pythagorean theorem. That's going to be our most accurate because these ones are given to us. We know that these are exact. The angles, we're going to be rounding them off. All right, so 16.3 miles, 15.4 miles. These are the legs. This one is across from the right angle, so this is the hypotenuse. So we know that a squared plus b squared equals c squared. In this case, c squared is actually t squared, and we can say this is 16.3 squared plus 15.4 squared, and that's going to give us that. So let's figure out what these numbers are. So 16.3 squared is 265.69. So 265.69 plus, and then we want 15.4 squared. That's 237.16. So 237.16 equals t squared. So let's add those two together. So 265.69 plus 237.16 equals 502.85. So 502.85 is equal to t squared. Remember, we don't want t squared, we want t. In a Pythagorean theorem question, the last thing we always do is take the square root. So t is equal to, and our square root button's right here, so the square root of 502.85 is 22.42. Let's do what we've been doing before to the nearest tenth, so 22.4. So this is 22.4, and that's miles. So that's how long t is. So this is 22.4 miles. Now we need to solve for our angles. Doesn't matter which one we do first. Let's do r. So I want to solve for r. I have this 22.4 miles, but you know what? I rounded that off. That's not exact. So let's use the two that are given us. So if I have r here, this is my hypotenuse, this is my adjacent, and this is my opposite. So r is equal to, we've got opposite and adjacent, so ka, toa. Opposite adjacent, I'm looking at tangent. So tan of the angle is equal to the opposite over the adjacent. So tan of, oh, I don't know what that is. It's r, is 16.3 over 15.4. So remember, I'm looking for an angle. I need to use the inverse function. So that's tan inverse of 16.3 divided by 15.4. That's exactly how I'm going to put it into my calculator. Again, if you have to do the numbers first, make sure you do 16.3 divided by 15.4 equals, and then take the tan inverse of it. So I'm going second function, tan, and I've got 16.3 divided by 15.4, and that gives me 46.62. Degree angles, we've been going to the nearest degree, so 46.6 tells us to round up, so that'll be 47 degrees. So r is 47 degrees. Now we could solve for s, doing the same thing using tangent. This would be the opposite now, and this would be the adjacent. We could solve for it, but you know what? If we're saying this is 47 degrees, we can do a subtraction with the angles just like we did before. So s is 180 degrees minus 90 degrees minus 47 degrees, which is just 90 degrees minus 47, which is 43 degrees. So I know that this angle over here is 43 degrees, so R is 47. S is equal to 43 degrees. I should say that's angle S and angle R. And that is, now our triangle has been completely solved.